Everything you do in life, you make a decision. Every action you take, every move you make it based on a particular decision. Now, the decision you will make and the actions you will carry out based on the decisions you carry out are done by a particular condition. What do I mean? I can make a statement like this. If it rains, I will go. So the question is here is this: when will you go to school if it rains? That means that if it doesn't rain, you will never go to work. School. Which one is important? You going to school or the rain? It is the rain. Because whatever happens, if there is rain or not, whatever you'd want to do will not be done if there is no what? Rain. So in this statement like this here becomes the condition that you base your action on. So the most important thing in a statement like this is the condition. If I was to rewrite this in a programming way, I'll say if condition, then action. So if I am able to satisfy a particular condition, then I'll perform a particular work. Action. It is here that we must understand something going forward. Your job is to manipulate the condition. Because you would only do this action based on this word, condition. Your job is to isolate a particular variable so that it will do a particular condition action. Sorry. Your job is to manipulate a particular variable so that it will perform a particular action. How do I then manipulate a particular condition? I'll manipulate a particular condition by comparing them. Now, the word comparing here brings about something else. And if I'm going to be comparing stuff, then it means that I need to have a way that I can compare them. So what tool will help me compare them? The tool which will help me compare them is the relational operator. This also brings the question, what is a relational operator? A relational operator, we have greater than, less than, greater than or equal to, less than or equal to, not equal to, sorry, not equal to, equal to. What would the relational operators do? They'll allow us to perform a relational expression. What is a relational expression? A relational expression is an expression which gives true or what? False. That means if I do something like 1 plus 5, 4, this is an algebraic expression. I can't use algebraic expressions for my conditions. Let's recap everything we've said. The most important thing in an if block is the condition, because if the condition is not met, an action will not be what? Performed. How will a condition be met? When it is evaluated and it provides an answer of true or what? False. Anything else is unacceptable. That means I can't put 1 plus 1 there, x plus times y or something like that. I can only put relational operators comparing themselves there. Because relational operators comparing themselves will give me a true or false answer in which I need to evaluate my condition. To evaluate my condition. What do I mean by evaluate my condition? If x is equal to 5, y is equal to 7, z is equal to 10, and k is equal to 3. X, this y will give me what? False. So x is 7, y is this. Is 5 greater than 7? No. So we will have what? False. This is a relational expression. This is a logical expression. So the answers we'll get from our expression should give us true or what? False. If I was to do this, this will now give me what? True. Because we said anything that this one does, and this one we evaluated, give me what? False. And then this one will not it, will negate it. And the negation of false is what? True. So it means here the answer is going to be what? True. You see, this goes even further, where I can say, if there are people in the room and they are moving, put on the camera. So you walk into someone's house and then you walking in the house and then the camera will be watching you, and then when you leave, the camera stops because there's no one there to record. It makes no sense for the camera to record when there's no one there. So it goes further than that. But you see, this question here will evaluate, are there people in the room? Yes. Are they moving? Yes. So I will do what I have to do. And you see, we cannot compare more than two things. So I can't say, for example, y greater than x greater than k. I can't say this. I can only compare two things at a time. So if I want to compare more than two things, logically, it means I need something else to help me to do that. And what else do I need to do that? I need a logical operator. And what are logical operators? We have the and we have the or. Now, we've seen this in your mathematics, whereby you do nege, po, nege, that thing. So in that expression, we would say that if y is greater than x, and at the same time, y is greater than what? K. If I want to use the end word, then it means here would be the double end signs over here. And if I want to do the or word, it means here would be the double pipes. Those are these two things over here. So let's evaluate this condition here. Is y greater than x? True or false? Based on the information we have over here. Is y greater than? Yes. Okay. So it's true. And is y greater than k? True. So if you have a statement which is true and a statement which is true, it should give you a statement which is true. It only give you false when one of them is what? False. The same thing applies to this. So here I have to choose between this or this. And of course, to give me one. Let's flip it. Let's change this one to x and this one to what symbols did I have at the top there? I had y. Already out that there, right there, okay, here, so he can do that. Okay. Good. Here will be z. So let's mix it up. Now, the first statement, again, y is y greater than z. False. Okay. False. And then the next statement. And is y greater than k? True. So this will give me what? False. Because we can't have two. The only way it can be true is when both statements are what? True for n. But there's a section here. Is x greater than z? No. So it's false. Or is y greater than k? True. So this statement will give me what? True. Why? Because with the or, we only need one of them to be what? True. For it to be what? True. So for example, if this was a car environment, we'll say if the person has the key on him and he's in the car, or the key is in the ignition, then you can spark the car. Other than that, don't spark the what? Car. So in such a scenario, which one will I use? I would use the what? Or. Because one of them has to be true for it to what? Spark the car. We are saying that the condition here has to be met, and it must be met to give you an expression of true. With that in mind, how then will I write an if statement? So let's write a small program. A program to determine if a number is even, full stop. What does this program want us to do? determine if a user's number is what? Even. What is an even number? A number that is divisible by 2 without a remainder. How will I write that in mathematics? But okay, let me rephrase. What is the mathematical symbol for divisible by 2 without a remainder? If I want something without a remainder, what is it called in maths? The what? The modulus. Mod. What is the symbol for mod? The percentage sign. So if I want to say, let's say x is my number, right? So x is 2. X is, let's say, 6. And I want to say that find the mode of x. The mode of x. Then all I have to do is say x percentage times 2 should be equal to what? 0. That means that if you divide 2 by x and there is no remainder, this is the statement that proves that. Again, I'm comparing this side with calculate. Whatever I get on this side, then I will come and compare it with what? This side. Now, I'm saying something interesting here. I'm saying that if we have a situation that has this scenario, then it means that the number is what? Even. That means that you will only enter this section here if you are a what? Even number. What happens if you're not an even number? Then, in this case, nothing will happen. We are only concerned with what? Even numbers. So it means if you are odd, we don't concern ourselves. Now, when the program tells you to find both even and odd, then you must concern yourself with the odd numbers. So we go back here. We are saying that if here we run this expression, it should give us a remainder. And if it is equal to 0, then we are saying that that number is supposed to be what? Even. I could change this one here from this to that. That means that every number here is now going to be what? Odd. Why is it going to be odd? Because this is saying that if whatever you do here is not equal to 0, then enter here. And that means that there has been a remainder found. So there is a remainder of 1 or 2 or whatever it is. But whatever it is not 0. So it means that since it is not 0, it means the number is odd. So it will enter here. But if I make this modification to my code, what happens to the even numbers? They also go away. So if I want to both find the even and odd, then I need to provide the else word here. The else here becomes an alternate to the if. That means that if this expression runs here and it gives you a false, then your job is to go to the what? Alternate. Because in life, we rarely make decisions which are concrete. There is also always a backup plan. If this man payday no come, then quick loan late. If quick loan said I've borrowed already, so they won't give me mommy day. If mommy says I've grown up and I'm too up, then the office friend is there. If the office friend says he's broke, then our wife is there. If our wife says she doesn't have back, then you go to prayers and bedroom. In a scenario like that, you realize that I went through multiple conditions, checked each condition. If it will satisfy a particular action, if it doesn't, then I move to the next one. Which means that there is not only one alternate. There are multiple what? Alternates. So in a situation like that, for example, in this situation here, the number can be even or odd, or zero. So if the person types in zero, what do we type? But so the person has typed what? Zero. So in here, I'm going to do some checks. What are the checks I'm going to do? Now, over here, I have this. If this condition is not met, I'm going to say else. And then in here, you are going to be what? Odd. But how do I know you are going to be odd? Else, if I check the condition again and you are not equal to what? Zero, then you are going to be odd. Other than that, I'll tell you you are undefined or the number zero. You can see that within this short second, I have done 3 forms of ifs. The first if was a simple if statement, whereby I check if something is true or false, and based on the condition it satisfies, I perform a particular action. In the second statement, I try if again, but this one, if it is true or false, I go ahead and go to the alternate and then execute if it is a what? A false. But for the third one, I have if, else, and another if statement, and they can go for a long trade. And for each one, I'm checking the condition to find where you what. Oh. Let's have another question. This time, you write the code in IntelliJ. So here's the question. Write a Java program that takes a student's score as input and outputs their grade according to the following criteria. If you have 90 and above, then you have A. 80 to 89, B. 70 to 79, C. 60 to 69, D. And anything below 60, you have a what? F. You have to write a program. I will open my editor. I will start a new project. I'll call this project Grade System. And then I'll click here. I'm here now. The question says or tells us that we are to write a program that computes a student's score as input. So before I can calculate your grade, I have to know what score you have. Exactly. So in here, for me to know your score, I need to ask you your score, right? So I'll start off by saying grading system. Over here, I'll do system. System. In here, I will do this. Over here, I have my system.out.print again. Please enter your score. After that, I have to accept the person's score, right? And I'll put the score where? In the variable. Now, the score, do I use int or I use decimal-based data type?
Yes, sir.
A double. So in here, double score, so that over here, I would say score is equal to con dot, but it doesn't work. Why? Because I have not created the object to the what? Scanner class. So scanner con is equal to new scanner into bracket system dot what? E. Over here, I can say con dot next what? Double. Now, if the person's score is greater than 100, tell the person that he has entered score is out of what? Reach. Else, so here we have our else statement. And then in here, you check if the score is greater than or equal to what? 90, then the person has a grade of A. I'll copy this for my speed. Else, if the person's score is greater than 80, then you have a what? B. Else, if the person's score is greater than 70, then you have a C. Else, if the person's grade is greater than 60, then you have a D. Else, you have an F. Let's say, hypothetically, that the score of the person is 87. What would this program do? It will come here. A score greater than 70. It is not. So it will come to the LC. Now, a score bigger than 90. Is 87 bigger than 90? No, it is not. So it will leave here and come here. Is 87 bigger than 80? Yes. So it will now come in here and display what? And the program will what? Stop. Let's see if that is what is going to happen. So if I run this, it compiles. I have no errors in my code. It asks me a question to please enter score. I say the score is what? 87. I press. It tells me I have a grade of B. And it is telling me I have a grade of D2. Why is it telling me I have a grade of D2? So let's see why it is doing that. Oh, yes, because over here, I didn't bring the what else here. So it is seeing that if block as a separate from the other if block. The else makes it so that it is a chain. So if it is not this one, then it's this one, it's not this one, then this one. But if I don't bring the else, it means that this is different. This is also what? Different. Now, over here, let me just bring a semicolon and a space here so that when I come back here again to enter another value, let's say I enter 90. Right now, the colon and the space allows that one to look what? A bit better, right? I press, and it tells me I have a grade of what? A. I refresh this again. Over here, I have 61, 62. I have a grade of what? It is working. The chain is very important. But note that the way I have isolated my conditions is also very important. Now, someone would want to do it this way, whereby they will check if the score is 90 and at the same time the score is less than what? 100. It is correct. Someone will want to flip it so that they'll start from the bottom and check the F's before they check the what? 8. It's correct. How you would manipulate the conditions is what makes you the programmer. The decision now allows us to manipulate the variables, and the manipulation of the variables, what makes the programming what it is. We need to learn how to let the application do what we want. Last week, we started learning objects when we were not in class. How then will I write this application as an object? Before I do that, I'll copy this code so that you guys can have access to it. So this is just me writing the code as a normal piece of code. The next thing I'm going to do now is I'm going to rewrite this code. I will save this. Let me just cut this out. Good. So I'm going to rewrite this code using a method. The method will be here. Remember, a method is a piece of code we call upon to perform a specific action. So over here, I'm going to create a method here. The method has to be public because it is here. The method has to be static. Why does it have to be static? It is static because this method is in the main function. And if it is in the main function, then it means that it will not change its values during the lifespan of the program. The structure of it will not change. That's why the static is there. So in the main function, you can't create something to it which is not also what? Static. If it was outside, then there's no need for me to create the static. But since I'm telling the computer that when you load this in memory, this thing will never change. It means that everything in it should also never what? Change. So I need to bring the word static. I need to also bring the data type of which I would be using for this. The data type I will be using is what? String. Then the name of it. The name is fetch grade. And then in here, I would give my parentheses in which I have to put in a parameter if I want to or not. In my case, I want to. So the parameter I'll put in here is double S. And then I have my body. In my body, I will put all the code we did over here, there. But again, I called my thing here S. So it means that everything here has to be what? S. Good. Good. What is the problem? The problem the computer is trying to tell me is that I said that this application here has a string. If I change this to void, the error you see there goes away. Can you see that? If I bring it back to string, the error appears again. If I say that if I tell the computer that my method is going to be void, like how this one is saying void here, there is something important I've told the computer, that when I call on it to run, and it is done running, that thing would be saved by it. So it would contain a void or empty space. So it is what? Void. If I put in a data type over here, that means that when I'm done running my program, I should return to it a value that is of the same type as my data type. So if I'm going to be returning something here, then it means in here, I need to make a small adjustment and then create a variable here called string result. And instead of me displaying everything, I am going to say result is equal to that. One second. That means that here I can return what? Result. Now, in my main function, let me just copy this. 1 second. Good. I have this. But in order for me to calculate the grade, I need to go and fetch or call upon the function grade, fetch grade to calculate the grading for me. So in here, I need to go and call upon. How do I call upon it? I need to mention its what? Name. And you can see the computer already tells me that for me to complete this name, I need to complete its signature. And what does this signature contain? I need to enter double S. I need to enter a double value, and it will be saved in a place called what? S. In my case, the double value I'm saving is what? The score that I have gone for from the user. Now, when this thing runs, it will save on itself the answer. That means that all I have to do is say system.out.what? Print. And this should print the method in which I have called. And you can see that the code from the main method is this. And then all the calculations are done somewhere else. Now, why is this necessary? You see, if I would be calculating the grade in multiple places, for example, if you have a student portal, you'll be calculating the grade in the transcripts. You'll be calculating the grade in the provisional results slip. When the lecturer is uploading the grades, you'll be calculating it there. When they are going to do moderation, you'll be calculating the grades over there for the graph sheets that you draw. I do not want to rewrite this code over and over and over again. So I will write it once, and whenever I need it, I will call upon it to be what? Executed. Now, as a professional programmer, the use of your method or function, because Java is called methods, in C++, now it's called function, is very, very important. Because as I said, the whole concept of code reusability, code coming down, comes from this, whereby I don't have to reuse the code multiple times. And if the school, for example, says that we are changing our philosophy because the number of people who are getting F is too much. So now F is not 60 anymore, it is 50. I only have to make that change in one place. That is where? Here. Unlike the other one, if I had to rewrite this code in those 4 multiple places, instances. I have to go to all of those four and make the what? Change. So it makes code maintenance for me very, very easy. So the same program we did, I've rewritten it using a what? A function. And if I run this, it behaves just like the other one. So over here, when I enter a particular grade, the grade will be collected on the screen at this point. When it is collected, it will be given to my function through this parameter. When it is given, it will go from here and come directly to where? Here, and continue. In continuing from there, it creates results. It checks if this is that. If it is that, then it will go to result. If it is that, then it will come here and then it will run. When it gets here, whatever resource has is saved upon itself, which means that at this point in time, I will jump from here to go back to here. And I'm telling the computer that display whatever that thing has saved on itself. So it means when I press this button here, I should see what they see, because whatever that is saved on itself is what it will show. And I cleverly said it should save on itself a string, which means that I can write whatever I want to be displayed, and it will display that for me. The same program using functions. The idea is to get all of you to go to objects. The idea is now all the programming you see are in object form, whereby everything that is integral to the code running is hidden from the user. So you, the programmer, will code everything in the back, and all the users will see is just things working. For example, if this was a production code, all you will see is the code I have over here. And when you see this, what do you see there? Oh, go and fetch the grade. So I just have to put the grade in here, go and fetch it from. As to how it fetched it, as to what calculation was done, as to how the calculation was done, you, the user, do not care. It is none of your concern. Your only concern is that the program will what? Run. But for you, as an IT person, you care about how the code is hidden, how is it hidden, how is it showing, and so on and so forth. And then there are clear advantages. If it depends on what you want to do. If you want your code not to return anything, you can, but it means you have to make it a what? A void. But you see, how will I say this? You do not want the function to have the burden of the display. You want to control the display. For example, if, let's say, I build a website and it has payment in it, and the payment is from Momo. So it means I would have to send MTN certain information as to the Momo transaction I want to do. For example, who am I sending the Momo to? How much am I sending? The purpose of which I'm sending, so on and so forth. MTN will receive this information and process it, right? Do you want MTN to reply to the people and tell them that, oh, you do not have money, that's why you can't do the transaction? No. You want to control that. So when you go to MTN, MTN will reply with a flag or like a code. So like if it is 001, then it was successful. If it's 002, then it means the person didn't have money in his account. It was 003, network error. So when you receive the code that is 001, then you will tell the person what has happened. So you can say, oh, So that the person doesn't feel bad. Oh, sorry, you have insufficient funds, come back another time, or something like that. So you see, here, if I did the display here, it means that the function has the onus to display to the user directly what the error is and what it is not. Now, if I do that, it means that I am using it for a particular purpose. Hence, I can't use it for the other places I have to do. It means that, like, for example, over here, if I have 10 courses here in which you did, let's say this semester you guys are doing 4 courses or 5, 4 or 5, 6 courses. And I wanted to know the grade of each of the 6, right? I don't want the set grade to display it because maybe in your provisional results, I have a way I will display it there. In your transcript, I have a way I'll display it there. So all I want is to know if you had A, B, or C, how I will display it. The transcript page should take care of what? That. So you want your function to do its function, to do what it is called to do. You go and calculate grade. So what will it bring back to you? The grade. For example, if I was doing this technically, I would not even write grade of C. I'll just write what? C. So that when I get it, how I want to display with it and what I want to, then that one can take care of it. So normally we want our function just to perform its job. The display, something else will handle the display. So that your code will be modularized, so that if there is a problem, you know who to go to. If there is a problem with the display, you know that, oh, this thing handles display, so the problem is with what? That. So on and so forth. Does that make sense? For example, here, I could create a function whose job is to go and ask a question. Let me put it this way. Say here, okay, I had to ask the person, what is your class score? What is your, exam score? And then I'll add the class score and the exam score together to get your what? Final score. Then I'll go and calculate your grade. Are we okay? Instead of me doing that, I could create a function whose job is to ask those questions. So to ask you, what is your class score? Take it. What is your exam score? Take it. My job, I'll just code that once. I will not have to code that repeatedly again. Do you understand what I'm trying? Are you sure you understand what I'm trying? I should demonstrate it. Okay. So we want the functions to go and do its job and come back. If you want it to display something, you can. But it means that if you do that, then that page would be, it will just be unique and custom to that page. You can't use it in other places. Other than that, if you are using it in other places, you have to factor in that in those places there will be changes. Those online, are there any questions? That's all. So for this one too, we have this, and then we have solution with a method, so that I can add the solution with the method. Hello. What place are you looking for? There was. I don't know where it is. When I come, then I just quickly close, so I don't even know where the classes are. I have to start knowing the environment. I'm here for class and then I run out. Consider a program that calculates ticket prices based on age. Children age 0 to 12 get a 50% discount. Adults who are 13 to 64 pay full price. Seniors who are 65 and older get a discount of 25%. We have to write a program to do this. Okay. I will start. I will start a new file project. I'll call this project discount calculator in this window. I have my main method here. Just for your sake, I am going to create two methods. The first method is to calculate the age. And the second one is to calculate the discount. But before then, I will write the entire program without the word function, so that we see how it is linear, how we can write it using word function. Because it's important for me, for you to see the truth and be able to understand the truth. Are we okay? Now, in the question we have here, it tells us precisely that we are calculating the ticket prices based on age. So what do we need to know to calculate your ticket price? You need to know your age. That means we need to ask the person to enter their what? Age. So here I'm going to ask the person to please enter age. Please enter your age. And with this statement here, the person would enter their age. But obviously, I would need the scanner class and I would need an integer age. Of course, I'm using integer because nobody can be the age 0.5 or somebody can be that. Okay. So here age is equal to that dot this. So now I have the age. If your age and your age is, so let me just bring this here, copy this, and then in here, I'll create a multiple line comment, and then just put this in here like this, so that I'll have everything here. So you can come here, and you can go here. That's fine. That's fine. Great. So that over here, what do I have? If your age is 0 to 12, then you have a 50% what? Discount. So over here, you're saying if your age is greater than or equal to 0, and at the same time, your age is less than or equal to what? 12. Then your discount is equal to 0.50. Now, obviously, the discount here is underlined because we have not created the data type here for what? Discount. See, every time I have an error, I know why the error is there. How do I know? Because I dwell on the knowledge I have that if I've used discount, I have to go and what? Declare it. So I can't use a variable I not what? Declare. Okay. Now I'm back here. Yes. Mm-hmm. Yes, you could. So over here, so we say this, you could have just said that. But or you wanted to be, or you mean this? Yes, we can do this. You could do this. But you should remember also that sometimes it's good for you to think of human being and our nature. Someone will type -2. Is -2 less than 10? Yes. Have you ever seen someone who is -2 before? No. So your program will say, but technically it is what? Wrong. So sometimes it is good for you to control the actions of the people. And it is also good for you to outthink them as to what they are going to do. I think it's fine, it's correct. So that if you want to go in this direction, then it means that you can also say if, else, if age is less than 64, else if age is less than, sorry, is less than oh, so for seniors it is above. So else, I guess say else because everything else will be above this, isn't it? So else, then the seniors can, right? But normally, I prefer not to bring the less than. It's a personal preference anyway. So I prefer to say, okay, if this one is less than or equal to 12, or this one here is we can let's maintain this, is not a problem. So this one, their discount is going to be they'll pay full price, so 0, no discounts. And then these people, their discount is going to be 25. I hope you know why I'm using 0.5 and all of those things. It's over 100, so to give you the lens value. So over here, we can just print out the discount the person will get. So discount, oh, sorry, system dot out dot print discount. You can put some nice writings here to see the discount is that. Of course, if you do that, then here you have to concatenate it with a plus. So you have this. What is your age? 34. my discount is going to be what? 0. So control manipulation, right? How you would control the conditional statement will allow you to enter or not. Now, at the end of the day, your ability to control the conditional statement is what is important. How the conditional statement must be ability to control. And also, what would you use the relational operator? Yes, that later that so on and so. For the last question, I will send it to you guys to do on your own in your spare free time. It is a program that would ask the person the time of the day and tell the person if it is good morning, good afternoon, or good evening. You should be doing that by default. For the other one, I will not do the function. I will leave it to you guys. Try your hands on it. When we come next week, we will do the function for this, the one in which I gave you for you to find how to beat the day. And then we will do the same things we did, but this time we'll do all of them as objects and see how we can move from methods towards objects. Programming becomes difficult when you start learning the concepts. You see, in our side of the world, we have to learn the logic because we didn't learn it in basic school. So that becomes hard. So people find programming hard because of that. You know, where do I start? What do I combine it with? Which one do I write? How do I write the line? Those become the problem. Now, when you start adding the concepts, it becomes even harder more because they're like, what is a function? How do you do what, you know? But in anything, practice makes you perfect. In programming, you cannot run away from the word practice. And unfortunately, you must practice with questions. And students normally become frustrated and they lose interest when they can't solve the question. There are lots of questions I cannot solve. It's not these questions, but there are lots of questions I cannot solve. The key is finding joy, finding the answer of why it is like that. That is the only piece of advice I'll give you. I'll be okay. We were supposed to do most of them in the classroom, but with most of your friends not here, I don't feel comfortable doing them in the classroom. And online too, some of them are sick. So asking them to do it as a task whilst they are watching is a bit cumbersome. So we must post here. Other than that, we'll go 2 for it and then it will become a problem. But next week when we come, as I said, we'll redo all of these ones as objects. And once we can understand them, then we will move to what are loops. And then we have the for statement, the for each statement, the while statement, the do while statement, and so on and so forth. What are these statements and how we can use them? Are we okay? Are there any questions? Also, I would be sending you guys 4 videos to watch. They talk mainly about the if statement over again from a different perspective, the for statement, and then methods again as in a different perspective. So during the week, try and watch them and try and do the questions which are that are real. Then we'll meet again next week. You came to close us. Why you were coming from Kaswa?
Yeah.
I see. Those online, thank you for coming. Okay.
Thank you, sir.
Bye.